is right there. 1, 1 is right there. Right? So the points that we got to work were 0, 1, negative 1, negative 1. What was it? Yeah, 1, 1. You guys with me?
Yes.
What seems to be true about all those points so far? They're all on that side. Yeah. So if I kept going, let me see. What about 3, negative 5? Dude, what's 3 plus negative 5? Negative 2, which is it less than or equal to 2? Yes, and sure enough, 3, negative 5 is on that side of the line. Therefore, I would shade that way. That means that every single point that is on that side of the line works in this inequality. So this gets a little bit freaky. How many answers are there to x plus y equals 2? How many answers are there? Infinite number, which is why we graph it to answer that damn question. So as we try to list the answers, we ain't never going to be done. But I want you to realize, the minute I put an inequality on that sucker, there's even a bigger infinity of infinite answers. Because now it includes not just all the points in line, but all these points too, and that whole, holy shit. Okay. Anytime you involve an inequality, there are going to be more options that work. Because it doesn't just have to equal, it can now be bigger or less or whatever the inequality is. So, here's the key thing. Here's something I haven't done yet, because I just want you guys to get that idea down. Do you guys remember, why did I put why did I put this kind of a symbol here? Why didn't I put a parenthesis? Yeah, because it was allowed to equal. A parenthesis would be like an open circle. It would mean you can't go here. Same thing's going to happen with these. So what if I had a piece of paper? Man, can you imagine? There we go. All right. What if I had a problem like this? Y greater than negative 3x plus 2. Sure. Something nice and quick. The numbers, the points that are on this line no longer work. Because if I graph this line, these are going to equal y. Am I allowed to have these equal y? No. So just like up there, if it was greater than 3, I'd have to put an open circle, or what's newer is the parenthesis, right? So what we do, whenever it's a strict inequality, it's not allowed to equal it, we don't make a solid line. So we recall that the y-intercept is 2, 0, 2. What's the slope? Go down 3 over 1. So instead of making a solid line, we make a dotted line. That's kind of like our parenthesis or our open circle. Same idea. The points that are on the line make this equal this. That's not allowed. So I can't include them. So let's see. What point is this again? I mean, not again, but what point is that? 1, negative 1. Let's put it in. If I put negative 1 greater than negative 3 times 1 plus 2, is that true? Is it ever cool that I put the point 1, negative 1 in? A 1 there and a negative 1 there. Is negative 1 bigger than negative 3 plus 2? Is negative 1 bigger than negative 1? No. So a point on the line does not work because it's not allowed to equal the line. So I have to, instead of making one big ass open circle, I make the line dotted. It means the same thing. But now which way do I shade? That's still the question. Yeah, 0, 0. Is 0 bigger than 0 plus 2? Is 0 bigger than 2? No. Oh, I forgot to show you my shortcut. I'll do it now. Do you see how this says y bigger than this line? Where are the y's bigger than this line? Up. So I'm going to shade that way. That's kind of like the shortcut. You don't have to do the test point. If you look at every other problem we did, y bigger than or equal to, shade it up. Y less than or equal to, shade it down. Or you can use a test point like we did. Either way. I like it. Hey, Mikey. All right, so you guys try this one. Is that the one we just did? Yeah, it is. So you guys try number 2. Let's make it more interesting. I forgot that was. Yeah, that's where it came from because I'm not creative. Try number 2. I just put that there so you know if you get to the right equation. If you don't see how I did that, well then don't look at it anymore and just do it yourself. And then you'll see how you get there. Let me catch up to you guys. The slope is -3/4. What's the y-intercept? 0.3. I like it. So 0.3. Then I'm going to go down 3 over 4. I like it. So there's my line. What kind of line am I going to make though? Dashed. I like it. Or dotted. There. I always say dotted. It's crazy. Little dotted dash line, bam. All that is exactly the same thing as an open circle. They mean the same thing. So I know for us, it's a big deal when I step up the number of dimensions I'm using. Even just saying that sounds freaky still, right? Let's go to the next dimension. It's like, what the hell am I doing? Is this a movie? What am I in? Well, now we just know the next dimension just means the y's are included. Ooh. So, but the math doesn't give a shit. It's still, there's got to be dividing something between yes and no. And in this case, when there's 2 dimensions, it's a line that divides it. And now I got to have a way to figure out, well, which side is yes, which side is no, which side works, which side doesn't. So if again, 0, 0 is an option. So when I put 0 plus 0, is that less than 12? So which way do I shade? So 0, 0 worked, so I'm going to shade in the direction of 0, 0. It's on the side that works. There you go. Or if you look at it my way, less than, down. Bam. What about number 3? Since I've given you a plane, I want you to graph it on the plane. So you have to think about what would y equal -4 look like. And that's what you plot first. Is it going to be solid or dotted? Dotted. I love it. So you should know what y equals -4 looks like. And then you're going to put a dotted line there. So remember these two special cases. Which one is going to be straight up and down? What kind of line? X equals or Y equals? Straight up and down would be X equals. So the way I remember this is X equals, this sucker is going up and down like crazy. So there's no restraint on Y. Y can go crazy up and down. X equals something. That's why it's not moving left and right. X can only be that one thing. And this guy would be a Y equals. So I know this sucker is going to be a horizontal line where Y is always -4. So it's going to be right there. You can make whatever sound effect or not you want to. And then which way? Just use your gut here. These special cases are a little bit easier. I mean, I don't have to do any special anything. It's just greater than, so I'm going to shade up. Yeah. Okay. Yeah. I like it. I mean, technically you can just shade, but I am trying to get you used to the arrows because we're going to have two lines at once at one point. And if you do shading, it just gets really gross to try to figure out what your answer is. So, all right, let's look at number 4, and then I want to show you what this is leading to. So based on what we just did, what kind of line should x equal 0 be? All right. It's going to be solid, but is it going to be straight up and down or horizontal? Up and down, vertical. At 0, right? So where is it? What's another name for x equals 0? Straight up and down. Yes, the y-axis. So that's another name for the y-axis. It's going to be a solid line going right through the y-axis. And I want the x's to be less than that, so I'm going to shade to the left. I like it. So, where this is headed, if anybody worked at a construction site or, and there could involve some electricity there or anything involving loads physically or electricity loads or anything like that, you have these ideas of safe zones, these restrictions. So you could have a situation where, all right, you got to be here, or else if you're not up here, then things are going to explode. But at this, so maybe let's say, what would be a good example, Jeff? I don't know. If you don't put enough power into the system, it's going to like seize up or something. But if you put too much power into the system, so that you got like a ceiling here, so you got to be below this. If you put too much, then it's going to blow up. So here's your safe zone to be in. So whenever you see like a dial that has like a green, yellow, red to it, you can see it creeping up. Very often the background is these things. It's a series. No, this can't be too hot, and this one can't be too cold, and this power can't be turned on too high. And all three of those things kind of come together to show you where the safe zone is. So it could be creeping towards the red for any of those. Once I'm starting to get towards one of the boundaries, if I'm at that point, I'm in the red. It's about to blow up. Go check on it. So that would be multiple, like maybe it's x plus y, greater than or equal to 7, and x minus y less than 3. And you have multiple equations related to all those things that have to happen so that nothing blows up, nobody dies. The machine doesn't stop working. Does that make any sense? So these are restrictions based on, for example, so many people on an elevator. Right? Have you ever gone into an elevator that says MO7 people and the 8th person and you're like, What's right? I ain't playing with this shit. I've seen too many movies involving elevators. Old ladies with devil. Oh shit. I just gave a spoiler away. All right, 2 minutes. Okay. So that's kind of like where this would eventually go to. So I always want you to realize a lot of what we're doing does feed into something that you see that is necessary, that sometimes saves lives, right? This mathematics is used for those things. Okay, but I think that's pretty much all I want to talk about. I like it. Coolness. So it sounds like it's not raining at the moment.